Cool. Cool.
All right, I think we're on now, Ava. How's it going?
Yeah, good. How's it? I mean, the camera looks really good.
Yeah, you can see me? All right, I think we're on now, Ava. How's it going? I get it. Hang on, I gotta kill that echo. Hang on a second.
Really good.
Yeah, you can see me? All right, I think we're on now, Ava. How's it going?
Oh no.
Stand by, stand by. There we go, there's Ava. All right, anyone on the stream? Oh, Julia, I see Julia, Corey, Alyssa. Hi everyone, I'm Dr. Michael Faison. Nice to meet everyone. Hope you can hear me. Hope you can see us. I'm up here at the Lightner Observatory and Planetarium. I kind of threw everything together in an hour or so. Oh, I see Austin. I see Ellie. Hello, everyone. I just ran out here an hour ago or so, and there was a big scary raccoon over by the 60-inch dome that I had to scare away. But I think we're good. It's not very clear, but it's clear enough to see the moon and the planets. And you can see the 12-inch telescope here to my right. Ava, are you still there?
I'm still here.
Okay, great. I think I've got your audio taken care of, and I hope you can hear me and so forth. So what I thought I'd do is just do a really quick demo of the kind of observations that we do here at the Lightner Observatory. And this is more just for fun. The camera that I have on the telescope, you can kind of see that little red hockey puck over there. The camera that I have at the focal point of the telescope is not the most sensitive camera that we use for some of our projects, like star clusters or supernovae or asteroids or anything like that. It's more a camera than for fun, quick astronomy. So we just got it this past spring for doing astronomy labs where we have students look through telescopes, put their eyeball to the eyepiece and look through the telescope. And sometimes we want to look at fainter objects. And so I have this camera that gives us a live video feed, and I'll show you that here in a second. I'm going to hide Ava, and I'll just show you what I'm doing up here. At any point, if you have any questions, post them in the YouTube live chat, and I'll try to see them, and if I miss any, Ava will shout at me and say, hey, so-and-so has a question. And if anyone has any requests, we can also try that. Now, I'm going to do something a little bit dangerous. I'm going to try to move my camera and point at some interesting things that I'm seeing out here. I am actually on the observing deck at the Lightner Observatory. So the dome behind me is where we have our 16-inch reflecting telescope. And we could go in there and look at it, but it's kind of a mess because I'm in the process of installing some automation equipment that will allow us to control the telescope and the dome remotely so that we can do research projects remotely without anyone having to be here to do it. We already have that for this telescope. This 12-inch reflecting telescope next to me can be operated remotely. But I thought I would come outside because it is a nice warm night. I've got my friendly raccoon over here. I've got my nice cup of coffee right here. I've got my ridiculous 2x42 binoculars right here. And I'm going to try this to see if I can move the camera. Now that may make my video cut out, so if it does, I'll have to fix it, but I'm going to try this. So I come over here and I point at the telescope a little more clearly. You can see there's a 12-inch reflecting telescope on a Paramount robotic mount. So the red part is the telescope mount and the blue part is the telescope tube. This is the same mount that we use with the 16-inch telescope that's in that dome over there. Right? You can see a little bit of the dome right there. It's getting washed out by the light. It's the same mount, so it's a very robust research-grade mount. It was donated to us by an alumnus about 5 years ago, And we're planning to set it up as a remote observatory in a dark part of Connecticut sometime over the next couple of years, probably with a bigger telescope than the 12-inch, but the 12-inch is one that we had in storage here. That 12-inch telescope was our main teaching telescope before we bought the 16-inch telescope in 2006. So I remember that. If I just kind of pan around, you can see there's the moon over there. We've got a nice gibbous moon tonight, not quite full. We'll point at that with a telescope, although it's going to be crazy bright and crazy magnified, but we'll try that. Maybe we'll do that first, actually, because it's not too far from where the telescope's pointed right now. If I pan over here, you can see downtown New Haven. You can see the planet Jupiter. So that's probably, the moon and Jupiter are probably the only bright things that you'll be able to see through this camera. So you see the red down there at the bottom is the I-95 bridge, the Pearl Harbor Bridge. And you can kind of see, maybe you can't quite see it from that angle, but you can see the Masons Temple down on Whitney Avenue. I always forget the Masons are there, unless I'm out here on the observing deck. We have a great view of the bridge, and in fact, if you know where to look when you drive over the bridge going south through New Haven, if you look off to your right as you go across the bridge, you can see the Leitner Observatory domes from the bridge. Sometimes when it's cloudy and we set up the telescopes, we'll point our telescopes at the bridge and watch cars go over the bridge, since that's something that we can easily see. And then way over to the right is the dome or to the left is the dome for the 8-inch refracting telescope. This is a great telescope. It's a historic telescope built in 1876 in Ireland, and it came to Yale in 1882. It was in storage for a long time, and we got it out of storage in 2004 to set it up here at the Leitner Observatory, which has only been open since 2005. And we use it mostly for visual observing. We don't really ever put cameras on that telescope. We point it at interesting planets and double stars and star clusters for public night outreach, or for labs that we're doing. Okay, am I still going out to the world? Looks like I still am. Okay, so what should we look at? I don't know, Ava, do you have any requests?
The moon sounds good since it's, right there. We're talking about doing that first, right?
Yeah. Start strong here, especially since who knows if my laptop's going to break or the telescope's going to break or the stream's going to die. So yeah, let's go to the moon. So what I'm going to do is switch over to a view that will let you see what the camera is seeing. So, and I think also I can show the map that lets me move the telescope. So let me transition to that. Okay, so this is some software that I'm running on my laptop that we use to control the Paramount mount. It's not connected to the telescope, it's connected to the mount. And the mount is computer controlled, it knows where it's pointing. If I command the mount to go to particular coordinates in the sky, particular right ascension declination, or if I go to it to tell it to go to a particular catalog object that's at a known coordinate in the sky, the mount can point at that. So the moon is pretty much due south from where I am right now. So if I go over here and click on the moon, and what I might want to do is actually just say find. There's the moon. There it is right there. Okay, so I'm hoping the telescope won't flip over. Let's see if it flips over. I'm going to click on the slew button, which is astronomy talk for move the telescope. And YSPA alumni know that you're supposed to shout slewing really loudly when you do that. All right, there it goes. Oh, the telescope's going to flip over, but that's all right. It should be fine. It should still be able to find the moon.
And then, Michael, you have a question from James about Jupiter. Yes,
James. Let me see what your question is. Just out of curiosity, how do you know that is Jupiter? Are you familiar with the night sky, or did you know where to look on this night? Yeah, that's a great question. I have been looking at star charts for teaching for like the past 5 weeks, and before that I was doing a live stream for the Tuesday night public night during quarantine. And so I've been keeping up with the sky, and I know where it is. If you're not sure, you see something bright in the sky and you think it might be a planet and you're not sure, One thing you'll hear is, oh, the planets don't twinkle, the stars do. That's not necessarily true. That's sort of true, and the reason why is because the planets are bigger. They have a bigger angular size, so when they wiggle around, their brightness doesn't change as much. But it's worth sort of learning where things are in the sky, especially where solar system objects are. Solar system objects are always in the plane of the ecliptic. So where's the ecliptic? Well, the moon is always in the ecliptic. That's the plane of the solar system. And if you're looking at my star map here, that blue line that you see going across the sky is the ecliptic. It's the plane of the Earth's orbit projected up into space. So the moon is in the ecliptic, all of the planets are in the ecliptic, the sun is in the ecliptic. So when you get used to seeing where the moon and the sun is and some of the bright stars that are in the zodiac, that will help you figure out where the ecliptic is, and then you always know the naked eye planets are in the ecliptic. And then as you get experience, you sort of realize, oh yeah, Mars is really red. So if you see a bright red planet in the ecliptic, it's probably Mars. If you see a dim yellow planet, it's probably Saturn. If you see a bright whitish planet, it's probably Jupiter. If you see a really, really bright planet and it's either in the western sky at sunset or the eastern sky at sunrise, it's almost certainly Venus. Okay, let's switch over to the camera and see what we see here. All right, I'm seeing a way zoomed in, out of focus image of the moon. So because I flipped the telescope over, it's going to be a little bit out of focus. So let me try to zoom out a little bit. I can't zoom out a lot, but I can zoom out a little bit. And I can't zoom out a lot because this telescope has a really long focal length. So if any of you do photography with like SLR cameras or cameras that have interchangeable lenses, if you want to zoom in on something, you use a long focal length lens, like maybe an 85 millimeter lens or a 130 millimeter lens. This telescope has effectively a 3,000 millimeter lens. So we're really zoomed in on part of the sky. Okay, let me work on focusing the moon. Now, we do have an automatic focuser here, but because I'm standing here, I'm just going to reach up and grab the focus knob and try to get it in a little bit better focus. This is a live view from this basically video camera that's on the back of the telescope. And there's a little bit of a delay, so I have to remember to not overshoot. So we're seeing the moon more or less non-inverted, the way it looks in the sky. Of course, zoomed in a lot. You know what I should do? I should have grabbed the joystick paddle for the telescope so that I don't have to use the software to move the telescope around if we want to look at different parts of the moon. Give me a second. I'm going to go grab that. Pardon the mic noise. I'm going to take off my headset here and go grab that hand paddle.
This is more of a question for the students, but are you able, so I'm also watching on the live stream, I don't have access to his computer. Are you guys able to see the moon, or are you just seeing the night sky app?
Okay, I am back. So I want to look at the part of the moon that's more in shadow. So you can see the Copernicus crater down there at the bottom, and the
oh, Michael, for the moment, we're actually just seeing the sky map still.
Oh, they're still seeing the sky map. Okay, hang on a second. There we go. You didn't get to see me focusing then.
Still traumatized from focusing that telescope last summer.
You know, it's so much easier. And, you know, I'm all in favor of making students work. I'm all in favor of students having a learning experience. But when you're automating things, like sometimes you have to make it easier. Okay, While I was inside, I grabbed the hand paddle that allows me to move the telescope, so we can move the telescope around while we're looking at the moon here. The other thing that I grabbed was the camera. This is the CCD camera that we normally use with this telescope. And for the iYSPA students, you'll be using this telescope. I won't be out here on the deck. Normally during on-campus YSPA, we make the students come out here on the deck and uncover the telescope and point it and focus it and et cetera, and then point at their target and get their data and so forth. But instead of using this video camera that's on the telescope right now, iYSPA students will be using the CCD camera, which has a built-in filter wheel. So instead of getting a color image, you'll get these monochrome images through the 5 different filters: clear, red, green, blue, and hydrogen alpha emission. And then you'll combine those images to make a color image that tells you about hydrogen emission. And I won't be out here on the observing deck. You will log in remotely to a different computer that will control this telescope and this camera, and then you'll get your images that way. Okay, let's look at the shadow side of the moon. So hopefully I won't move this too fast. There we go, we're moving over. Yeah, so now because the moon is almost full, we got sort of a gibbous moon. By the way, you know we have a partial lunar eclipse coming up. What is it, July? I can't remember if it's July 5th. Maybe, probably someone in the chat knows. But we're going to have a partial lunar eclipse, and it will be visible from North America. There was an annular solar eclipse about 2 weeks ago, right, when the moon was new and it was in line with the sun. But the moon was too small in an angular size. It was a little bit too far away to completely cover the sun and cause a total solar eclipse. So we saw a ring of sunlight around the moon. And let me zoom in a little bit so you can see a little bit. I'm going to raise the resolution and raise the exposure time. And I'm going to zoom in a little bit on some of these craters. Here we go. So this is okay focus. We get a lot of turbulence from the atmosphere here in New Haven. And we can actually just kind of scroll around and look at different parts of the moon here. Yeah, probably zoomed in a little bit too much. There we go. Hey, that looks pretty good. We don't need quite that much color saturation, so let me lower that. That'll look better. Yeah, now that's looking pretty good. Yeah, so we had an annular eclipse 2 weeks ago, and we're going to have a penumbral lunar eclipse very soon. I think it's in 2 days, in fact. And so you could watch it. You can see a very slight dimming on the moon when the moon goes through the brighter part of the moon, of the Earth's shadow. But there won't be any part of a total. It won't be a partial lunar eclipse. It'll be a penumbral eclipse. What you would see if you were on the moon is a partial solar eclipse by the Earth blocking part of the sun but not all of the sun. So I don't know if it's worth getting up to watch. You'd have to be really, really sensitive. You'd have to have really good eyes to see that the moon's a little bit dimmer than it normally is. Lunar eclipses are awesome and definitely worth getting out of bed to watch. And of course, total solar eclipses are pretty great. Annular eclipses are not as impressive because you don't see the corona. I'm assuming most people on the live stream have seen or saw the total eclipse in 2017, right? The Great American August 21st eclipse of 2017. All right, well, there's the moon. You know what? I'm going to save some images before we go on to another target. So I'm going to record. What you actually do here is record video, and I'm going to make the exposure time a little bit shorter so we don't blow out that part of the moon. And I'm going to record some video, and I'll share this with Ava later on, so that if you want to look at these images on your own, you can do that. Okay, so I'm saving the images.
So Julia had a good question. She was asking if you were just actively moving the telescope. I thought that was probably an atmospheric effect, but maybe you can confirm whether or not the distortions that we're seeing are atmospheric or...
Yeah, the shimmering that you see is all atmospheric. So the way the moon is kind of, it looks like we're looking at it through a mirage. That is entirely due to the atmosphere. And it's really quite dramatic because the moon has such a large angular size. So you're seeing a big patch of turbulent atmosphere when you look at the moon. When you look at a star or a planet, it's a much smaller patch of the atmosphere. So even though it wiggles around, you don't see the same degree of distortion. But I can totally move the telescope by controlling it with this paddle here. So, you know, if I want to scroll down to a different part of the moon, because I can't see the entire gibbous moon in the field of view of this camera on this telescope. It's just too much magnification. I'm zoomed in too much. Okay, I'm going to try and take another little video here. You can see down here in the lower left it says captured, how many frames I've captured. It's a very slow video because I'm using this over a USB 2 connection, so it's a little bit slow. When you're moving to look at different parts of the moon, what are you moving? There are motors in the mount here, and normally the mount is tracking the stars to the west as the Earth turns to the east. So there's a motor right here that moves the telescope east-west, and there's a motor right there that moves the telescope north-south. And when I press these, when I move the little joystick on the hand paddle here, or if I give a command to the computer, the motors move very slowly one way or the other to point at a different part of it. Oh, I see some clouds going by. You might see that. Oh yeah, we'll get some clouds coming in. We better go point at something else quickly before the clouds get us. How about if we go to Jupiter? I see Jupiter right over there. So let me stop recording video, and let's try swinging around to point at Jupiter.
Well, planets are definitely the most fun to look at from my personal perspective.
Yeah, definitely. Yeah, and you know, it's the kind of thing, planets are great to look at with your eye at the eyepiece of a telescope. That's one of my favorite things to look at with the 8-inch refractor that's in the East Dome. We get really beautiful, sharp views of planets through that telescope, very bright, sharp views. We get bright views through this telescope as well. I think this camera, this video camera, is good for looking at the planets because we can zoom in a lot compared to the CCD camera, which is for looking at very faint objects like asteroids and supernovae. This is for looking at bright things. Okay, I'm going to tell the telescope to move to Jupiter. So it's right there. And actually Jupiter is right next to Pluto right now. If you want, we could look at Pluto. You know, we could get 3 planets and a dwarf planet in the telescope tonight. Jupiter, Saturn. I see Saturn now over there to the left of Jupiter. If it's clear where you are, you know, if you're on the East Coast, you can go out and see Jupiter and Saturn over in the southeast sky right now. If you're on the West Coast or in Asia or some other time zone, obviously you're going to have to wait till it's around midnight in your time zone. But then you'll see Jupiter's the brightest thing in the southeast, and then Saturn's dimmer and a little bit down and to the left from it if you're looking in the northern hemisphere. But I want to go to Jupiter, so I'm going to click on Jupiter here and command the telescope to move to it. Now I know the telescope's going to flip over, so you know, iYSPA students will have to explain that in detail. When you are planning to observe an object, you want to know, is it on the west side of the sky or the east side of the sky, so you can prepare to move the telescope to that part of the sky. So we're going to go to the east side of the sky to look at Jupiter right now. So flip over.
And then a little bit back in the chat before all of the planet enthusiasm, dwarf or otherwise, there was a good question about humidity and how that affects the atmospheric effects that we see.
Yeah, it's very humid tonight, and that doesn't really affect the turbulence. That doesn't affect the seeing. It does have a couple of problems. It scatters more light. The droplets of water in the atmosphere will scatter more light, and it creates kind of a hazy effect, and that's why the moon looks so hazy. It also, if the temperature gets low enough, it can condense on the telescope. So one of the things we have to watch out for when we're observing late at night in the summer is if the temperature gets below the dew point and we start getting dew on the corrector plate of the telescope, which we don't have right now. So we do have a couple of ways to mitigate that. We have a dew heater band that we can put on the telescope if we know it's going to be humid and cooler. Or another thing we have is a hair dryer. We have an official dew zapper, which is a hair dryer, and we send the students out to blow hot air at the front of the telescope, and that makes the dew evaporate for about half an hour, and then you have to go do it again. Ava, did you use the dew zapper last year?
No, I don't think we needed to. It was so hot all year. The bigger problem was a couple of days where it started spontaneously raining while we were observing.
Yeah, that's actually a big problem because we're not going to have any observers at the observatory. I mean, I'll be here some of the time, but if it starts raining, we have to close the dome really quickly and throw the tarp over the telescope really quickly. Okay, let's switch over to the camera software and see if Jupiter's there. All right, I think I see Jupiter. Let me play around with this image and see if we can improve it. So I am going to have to change the focus a little bit, and I may want to actually use the telescope focuser because it'll be a little bit more precise than playing with the mirror. So if you could be patient with me for a second, I'm going to try to get the oh, I might not have it installed on this computer. I need the focuser control. Focuser control. All right. Here we go. Okay, that might work. And all right, so let me see if I can get that image a little bit brighter and a little bit better in focus. I have a little bit longer exposure time. All right, I think it's getting better. All right, so this is like astronomy eye doctor. You know, when you go to the doctor and they ask, is it better, is it worse? So we're going to move one. Oh, I see the moon. I see the Galilean moons now off to the side since I raised the exposure time. So that actually those will be good to focus on because those should be just dots of light. So let's see if the focuser is working. Ooh, yeah. Hey, it looks like one of the moons is right next to Jupiter. We should go look up which one that is. Yeah, that's probably a little worse. Oh, I should have quit while I was ahead. It looked better. Oh, now it's getting better. That might be as good as it gets. The thing is, Jupiter is quite low in the sky, and so when the targets you're looking at are low in the sky, they're going to shimmer a lot more. Yeah, hey, someone in the chat, go look in Stellarium or Sky and Telescope or something and tell us which moons are which. There's one moon right next to Jupiter right there, and then a moon on the other side, and a moon on the other side. And there's probably another moon. Oh, yep, there's a fourth moon further out. So I don't know if you can see my cursor on the screen there, but there's a moon really far out to the right, and there's then the other three moons are in closer, and there's one moon really close to Jupiter right there. Let's decrease the exposure time so that we can see that moon a little better. Okay. Now, oh, I see a shadow. Whoa, this is actually a really interesting situation. Now, the color balance is a little bit off. This is a really interesting image. I might even try to get it a little bit better in focus. But I can see one of the Galilean moons just a little bit to the right of the disk of shadow, just a little bit to the right of the disk of Jupiter. And I can see the shadow of the moon on the planet. Can you see that? I can also see the great red spot up here, and I can see some of the other moons over here. So I don't think it's worth trying to get the image in better focus just because it's not a focusing problem, it's a turbulence problem. You know, we're here on the we're here at basically sea level in the middle of a city, looking out over the city at an altitude, at an angle to the horizon of about 30 degrees. So this is just about the worst possible situation. Okay, Olivia looked up the moons, it looks like. Europa is on the left and Io is on the far right. And Callisto is on the far. So this one that we're seeing the shadow of is Ganymede. That's really cool. I'm going to take some video of this too. Let me actually really tweak the exposure time. When you're taking the video, it's actually better to have a little bit shorter exposure time, because then you can end up getting a moment of time when the atmosphere is steady and you get a little bit of a sharper view. And then what you can do is take the sharpest frames out of the video and add them together and get a much better quality image later on. So this is a technique that amateur astronomers use a lot. It's kind of a poor astronomer's adaptive optics. So instead of having a mirror that shifts, we're just taking super short exposures. Okay, I'm going to take a video of this. I love seeing that shadow. People will go out of their way to find out when will this is a mini Jupiter eclipse, a partial Jovian eclipse, or a moon transit, when the moon appears to move across the disk of the planet. By the way, the image is upside down relative to the real sky, and that's because the telescope flipped over when we went to the other side. So you can see the great red spot when the image is steady for a second. You can see the great red spot there, and you can clearly see the equatorial bands right there. And this is the north pole of Jupiter right here, and this is the south pole of Jupiter right here. It's looking a little bit less steady. I'm wondering if it's drifting out of focus again, but I don't know. I think this is going to produce a nice image, and I'm psyched to see that shadow. Everyone see it? Yeah, it looks like people can see it in the chat. Does the light pollution in New Haven affect your observations? Not really. It does affect long exposures on faint objects. And you'll see this when you take your images of your galaxies. Galaxies are objects with very low surface brightness, right? The spiral arms in the disk of the galaxy is not very bright compared to a star, right? So when we take images from here, boy, I'm probably filling up my hard drive with video size, 5 gigabytes. Okay, I'm going to stop that. When we take images of galaxies, often the edges of the galaxies will be washed out by the light pollution. But you'll see when we do the H-alpha project, because the hydrogen alpha filter blocks light except for that hydrogen, ionized hydrogen emission line, the city lights get blocked. And so even though there's a lot of light pollution in the city here, you can actually get a very nice image. The light pollution in New Haven has gotten much worse over the last, 4 or 5 years. And I think it's because people are switching from the high-pressure sodium vapor lights, the yellowish lights, to the really super bright LED, the white LED lights. So there's the street on Prospect Street is all brightly lit with these lights, which is great for security, I know this, but they're not well shielded. And to be honest, the lights here at the observatory are not well shielded. You might actually be wondering, why am I doing this observing with all of these lights on? And I can get away with it because I'm looking at bright objects and the telescope is pointing away from these lights. If we decide to go look at a nebula or a galaxy or something, I definitely will go turn off the brighter deck lights. But when I'm pointing at the moon or Jupiter, it doesn't really matter. Should we look at Saturn? What do you think about that? Should we go to Saturn?
Saturn's the best.
All right.
I don't know.
What do you think about Saturn?
Saturn's definitely just the best one.
It's even lower in the sky than Jupiter is, so it's going to be even more shimmery. But we'll totally see the rings. So let's go look at Saturn.
Yeah, we actually got up at 5 a.m. one time at Northwestern to do this, to go look at. I think it was Saturn, Neptune, and Jupiter, because it was Neptune nearby, and we were going to do it. Got up at 5 a.m. It was awesome. Skiing was terrible, though, because it was like March. And it was just...
Yeah, the telescope at Northwestern has the problem that there are buildings all around. But at least
Yeah.
if you look out to the east, you're looking out over the lake, so that helps a little bit. But there's also crazy... Oh, I was just going to say there's crazy light pollution there.
Yeah. Well, there's a tree that I'm always like, you know what, I love the foliage from below, but like the top 10 feet, we could just like, you know, lop off.
Yeah.
That'd be good. Yeah, but if you go to Northwestern and you do YSPA, you actually already have the code to get into our computer. They haven't changed it.
Not quite. Not quite. They haven't changed it since like 20 years ago when I was the observatory manager there.
Yep. Yeah, it's 3 fewer letters than you're using now.
Okay, there's Saturn. Anyone recognize that planet? Let's go with a longer exposure. I'll go with the auto exposure. And I want a little better contrast.
About this right now in the chat.
I don't know. Maybe it looks better than Jupiter. It might look a little bit sharper than Jupiter. It looks about the same as Jupiter. This is not the worst Saturn I've ever seen from New Haven, and not the best Saturn I've ever seen from New Haven. I would say it's within plus or minus 1 standard deviation of the mean quality of Saturn that I have seen in New Haven. Oh, a cloud's coming by. It's going to dim it's going to dim a little bit. Oh, it just went behind the cloud, so hopefully it'll come back. It's actually getting more cloudy, so we might be clouded out here in a minute.
Always a risk with astronomy.
Yeah. I'll raise the gain a little bit so it's a little bit easier to see. Hey, here it comes. I wonder if there are any Saturnian moons that we can see tonight around it. Should be possible to see Titan. As long as you know where to look. I mean, it's going to be the brightest moon. Oh, even though I'm raising the exposure time, it's fading out because of the clouds.
Still looks super sharp though.
Yeah, the clouds just make it dimmer. They don't really make it look more blurry.
Yeah, no, but just relative to Jupiter, I'm actually a little surprised, but thrilled. Saturn is definitely cooler to look at than Jupiter. I hope you all agree with me. That's the correct opinion. Saturn is just a better place.
Yeah, we saw that shadow on Jupiter, though. I thought that was pretty cool.
Yeah, that was cool. But I don't know. I'm a sucker for the rings. I like seeing the rings.
All right. Well, I'm waiting for the clouds to go by. This was actually predicted. I saw this on the dark sky forecast that it was going to start getting cloudy around 1 a.m. I can try looking with my owl eyes at the sky. I see Vega almost directly overhead. These are 2x magnification binoculars, which seems like they would be useless, but they've got 42 millimeter aperture lenses at the front. So you're just cramming a lot of light into your eyeballs, and it actually helps you see the dimmer stars really well. Let's see. While I'm waiting to see if it gets any more clear, I could take a few more questions. Oh, here it comes, out of the clouds. I'd like to try to get some video of Saturn to give to the students, but it's going to be tough with the clouds coming and going.
Oh, there's such cool depth in that, though. You can see how the rings are oriented.
You can, yeah, and you can almost see, the white equatorial bands.
Yeah.
And you can almost see the Cassini division when it's steady for a fraction of a second. I really like this camera a lot. Ava, I don't think you've ever used this camera, but
yeah, no, just the old CCD.
Yeah, Deborah inspired me to buy this camera. It's a long story, but I bought this camera for labs. You can actually control it using an iPad. And the idea is that we'll have some telescopes set up so that students can look through the eyepieces at things. but then we'll have this camera on either this telescope or another one, and we can show people deep sky, nebulae and planetary nebulae, the things that just look like little fuzzy things to your eye. We can actually show them a good image, an integrated image.
Very cool. Yeah, this is really cool, doing it this way.
Yeah, this is a lot of amateur astronomers are doing this, and they call it EAA, for electronically assisted astronomy. Eric, this is an ZWO ASI 533 CCD camera. All right, I think we're losing it, and it's getting pretty cloudy everywhere. In fact, Jupiter has vanished, and the moon is kind of coming and going. So I think what I'll do maybe is point at the moon for you one last time and see if there are any more questions, and then probably call it a night. So I'm going to swing back to the moon.
This is like the full actual observational astronomer experience. You get clouded out, you get to remote observe.
Mm-hmm.
Yeah,
and you have a real person like at the telescope doing stuff instead of just like a robot or having to control it remotely. Where's the moon? Where's the moon? It's over on the other side of the screen. Let me just find it here.
This is pretty much like my Palomar experience, actually. So
this is pretty much like what?
Oh, my Palomar experience. So for those of you who think astronomy for you, it's a good analog.
Yeah, so iYSPA students, this is what you're going to be doing. You're going to be using the software to point the telescope and take images. I'm using different software to get a video image from this camera, but you'll actually be using, I don't know if you can see it in the stream, there's a camera button right here, and if I had the camera connected, you can control the camera from here. All right, we're flipping over the meridian pointing at the North Pole. If you actually look at the telescope there, you can see it's pointing due north. And then it's coming back down, it's pointing to the west, and then coming back down, and it's going to point out to where the moon is over there. I could actually try to move the camera so you can see both the telescope and the moon.
Ooh, that looks awesome.
Yeah, you can see the clouds going by too. Okay, all right, so this is way overexposed now. So let me try and change that. And let me bring that saturation down again. Someone was saying that Saturn looked really yellow, and it does, it does look really yellow. Hey, it's still in focus. I thought I would have to refocus. One thing you can do with this camera is even though the zoom is too high to be able to really get the full moon in the image, is what I could do is I could take 4 or 6 images around the moon and then later on combine them in a mosaic. So I don't know, maybe I'll do that. I'm behind on the questions. Let me look at the questions here. So let's see. Do we have any narrow band filters attached? Nope, this is just a single shot color CMOS camera with red, green, blue filters integrated. So you get a one-shot color. That's a color view of the moon right now. It's not color calibrated. I would have to go through and tweak the color a little bit to make it color calibrated. For the moon, I like to just desaturate it a little bit so that it looks a little bit more realistic. You can see the Maria really well there. See the Sea of Tranquility there. We're coming up to the, 51st anniversary of the Apollo landings. My wife and I started watching the TV show For All Mankind the other day. I don't know if we're going to keep watching it or not, but it's one of these counterfactual histories where the space race never ended. And so it's kind of interesting to see that perspective. Let me pan the telescope over a little bit to see the shadow, the craters in shadow.
Looks like there may be some nebula requests.
Yeah, I would love to do a nebula, but
I'm guessing it's not.
pretty much the whole sky is clouded. And I was thinking what nebula we might try to look at. Of course, when the moon is out, the sky is pretty bright, so you know we have light pollution from the moon, as well as New Haven. You can kind of see in the camera, like that part of the sky is the only part that's clear right now. So, but it actually looks pretty cool through. It looks pretty cool there.
Yeah.
Let's see. Do you need to download the software to control the telescope? No, we will give you the account and password to log into the control computer and control it remotely. So you'll need to download software called TeamViewer, which is described in the participant's handbook, and TeamViewer will allow you to connect to the control computer. Lagoon Nebula, yeah, we could, if it were not cloudy there, we could try to get the Lagoon Nebula, or the Eagle Nebula is over in that part of the sky too. But it's getting late and it's getting cloudier, so I think I'm going to maybe take a little bit of video here with the clouds going by, and see if there are any last questions.
I will say for YSPA or YYGS folks who want to, last year Trustin and I took some cool nebula RGB shots that we never ended up actually combining, but they're on my Google Drive, so any of you can contact me directly if you want to see a nebula. You just have to combine the image yourself, which is actually kind of a fun little exercise. So.
Yeah, well, the YSPA students are going to do it themselves too, so
yeah, they are. But
they'll have their chance. They'll have a chance.
Yeah.
Unless it's literally cloudy for the 4 weeks from every night for the 4 weeks from July 13th to August 8th. Although we can still do remote observing if we have to.
Yeah, that kept happening to Team 2, I think, last year, where they just kept getting clouded out on Pretty Picture Night. But yeah, YYGS particularly, if you want to do this, because it's fun and it's only a couple of lines of code to combine them, or a little bit of software, or YSPA if you want another observation of something that I think Trustin and I grabbed at like 2:30 after all the students had left. So feel free to.
Ava, were you up past curfew?
We were closing down. We made a cool observation. I think that was the time that Trustin and I set off the alarm too, accidentally trying to close up. So that was an adventurous night for everyone involved.
I don't know if you can hear on my microphone, if the students on the live stream can also hear the sounds of New Haven. I hear fireworks, I hear police sirens. This is something else you're missing, both the young global scholars and the YSPA students. Being in New Haven up in the middle of the night, you get to hear all the wonderful sounds of New Haven. I thought I might see some fireworks. A couple of times I've seen fireworks out here, actual bottle rockets and things, but I haven't seen any. I haven't seen any tonight. All right, well now I'm actually losing the moon, and you can see you can see in the camera here the moon getting lost in the clouds. So this has been a lot of fun. Thanks, Ava, for setting this up with me and inviting your students, and also getting introduced to the iYSPA students.
Well, thank you so much for being willing to do this. I think this is a great opportunity. I know Francis was joining from Africa in the middle.
Oh, wow.
So this was a very cool opportunity for my students in general, but I hope you guys all got what you wanted out of this. I hope this was fun, even though we maybe didn't get to see everything you might have wanted to. This is still a very successful night. We had the coolest thing. So
Yeah, and if this live stream is going to be unlisted, so it won't be publicly available. But I can send you the link, and if there are any students who wanted to watch the stream but couldn't stay up or whatever, you can send it to them and they can watch it after the fact. And I'm happy to take questions from people about what we're doing some other time. So, all right then, I'll say good night then, and see you all again soon. All right, bye everyone.